Okay, let's keep talking about standard access lists or standard ACLs. All right, in the last video, we set up a standard ACL that blocks traffic coming from the 2 network to the 1 network over here. So source starting here, the direction is going this way and then ending up over here. So from right to left. And what we did was, if you look over here, this is the commands we put in. We did an access list 1, meaning a standard access list, and we denied 192.168.2.101, this host, and 0.0.0 is the wildcard bits, which signifies just this host right here. And then afterwards we put access list 1 permit any, and that means permit everything else. So everybody else is permitted, just so happens there's only one other host, right? So we denied one host and then permitted everybody else, right? And then we applied it to the interface FA01 on this router R0, and then IP access group 1. The 1 signifies that it's access list 1, and it's outbound, meaning going out of this interface. Now, why did we do that? Well, with a standard ACL, ACLs numbered 1 through 99 are applied closest to the destination. Well, if this is the source and the traffic's coming from here to here, then this is the destination, and the closest destination interface is this interface right here, outbound R0, right? Closest router to the destination, closest interface to the destination, which is over here, and then outbound, right? So we're going to continue now from here, right? And that was successful. And what we're going to do is, what if we wanted to also block all of a sudden 2.100? This is a bad guy over here. He's been doing some bad stuff, and we want to block access to 192.168.2.100 also. So we go into our router, and we're going to see if we can just add to our access list, right? We'll see if we can do that. So we'll say enable conft, and then we'll say access dash list 1, right? And then we're going to say deny, and then this time instead of just doing 192.168.2.100 and then doing 0.0.0.0 like we did the first time, this time we'll do it like this, and we'll say deny host 192.168.2.100. Now if we do that, that statement is going to be appended to our access list 1. But you're going to see that it's actually not going to work, and I'll explain that in a second. So we'll say Control C, show run for our show running config. Here's our configuration file, tab or spacebar, and there's our, at the end of our configuration file, our running config, you can see there's access list 1 deny host 2.101, and then access list 1 permit any host, and then access list 1 deny host 2.100. And this is not going to work. And I can show you that it's not going to work even though it says deny host 2.100. Unfortunately, there's a permit any host in front of the deny host. And the way the routers work is when packets cross the router, they apply the access list when it crosses the interface, and it's about to cross the interface, and the access list is read one line at a time. So it's read from top to bottom. So it looks and it sees if the source address is 100, and so it reads the first line and says, is the source address 100, right? Or it says, is the source address 101? Nope, it's 100, so it doesn't deny him. Then it says permit any host, and it says, hey, is this any host? Yes, it is. So then the permit statement is executed and the traffic is allowed through, and then the access list ends. So we never get to line 3. In other words, if I open up Notepad here, this statement is checked against the traffic coming across, and if there's a match, it's denied. Okay, and then that's it. Done deal. If it's denied, the packet is denied, and then we move on to the next packet, right? The rest of the access list is not checked once there is a match. All right, so once there is a match, the access list is exited, essentially, right? So the rest of the access list is not read. So when the traffic crossed, it checked to see, hey, is the guy 101? Nope. Okay, next line, permit any host. Is the packet from any host? Yes, it is. That would be all packets. So it's permitted. So we never get to line 3 where we want to deny. So this brings up an important point when we're learning about access lists, and that is you want to put the more specific statements at the top, right? And then you want to put the more general statements at the bottom, okay? Right? More specific statements at the top, more general statements at the bottom. So also, another thing that I want to point out, I'm going to comment this, and comment this, and comment this. Another thing that I want to point out is that in an access list, at the end of the access list, you will not see it, but at the end of every access list, there is an implicit deny all, or deny, in this case, any. So at the end of every access list, when you create an access list, there is an implicit deny any, and all traffic is blocked. Now, you won't see it, but it's there. So what that means is, if you don't permit anything, everything will be blocked. And so we'll talk about that in a second. Now let's go back to our access list, and we'll see that we've got this problematic access list here. We want to deny 2.100, but as you can see, if I go like this, he is in fact permitted. Just give it some time. You can see there's a reply. So it didn't work. So it did not work. So we need to rewrite the access list. Okay, so I've added one more host to the network here, and I'm going to rewrite this access list. So I'm going to go in here, conf t, and we'll say no access list 1. All right, now let's see if that actually did anything. Let's Control C, show run, and we see, is our access list there? No, it is not. I don't see our access list, so that's it. We got rid of it. Great. Okay, time to write the new access list. So we could say conf t, right? And we'll say access dash list, and this time we'll call it access list 2. Now access list 2 is also a number between 1 and 99, so it's a standard access list. It could be 1, it could be 99. We could even call it, let's say, access list 99, right? It's also going to be a standard ACL. And I'm going to say access list 99, deny host 192.168.1.2.100, right? Okay, so there you go. I'm denying host 2.100, and then I'm going to deny host 2.101, right? And then I'm going to leave it at that. So I've denied host 2.100 and 2.101, but I haven't written a permit statement anywhere, right? So remember what I said before, at the end of every access list, there is an implicit what? Deny any. And so what we've got here is deny host 101, and we've got deny host 100, or 100 and 101, right? But at the end is this implicit deny any. And so what that means is this access list is not just going to deny 100 and 101, it's going to deny everything once it's applied to a router interface. Now let's take a look at our router interfaces. So we'll say show run, and you can see that we have IP access group 1 still outbound, still applied to the Ethernet 01 interface. So even though we got rid of access list 1, we still have this application here. So we're going to copy that, right? And we're going to get rid of it. So we'll say conf t interface fa 0/1, right? And I'll say no, and then paste IP access group 1 out. So we get rid of that. But we need to apply our new one, so we'll do an up arrow, and we'll say IP access group 99 out. All right? So now, should be good. Show, run. There is our interface IP access group 99, access list 99 is now applied outbound on fast Ethernet 01. And we have our access list. Now what this is going to do is it's going to deny host 2.100 and 2.101, right? But it's also going to deny 2.102. So if we go to 2.102, our new host, you'll see that this new host is also unable to ping. Notice destination host unreachable, reply from the router, destination host unreachable, right? And that's going to be the same thing with these two. So if we don't put a permit statement, we actually write a very bad ACL in that nothing is permitted at all. So to fix that, in this case, if we put another statement in here, it'll be added to the end of our access list and it will work. So let's do it. Conf t, let's see here, conf t, sorry about that, access dash list 99 permit, right? And in this case I'm going to put a very general statement to permit anything else. So permit any, right? So we hit enter, right? And we do a show run. We take a look, we see our access list there with a permit any at the statement. Notice this is denying a single host, and this is permitting all networks. So from specific to more general or more to wider application. So we've put that permit any here at the end. So now what happens is before the implicit deny any, there is a permit any which will take effect before the implicit deny any, the invisible deny any, has the chance to deny all traffic. We permit all traffic, essentially wiping that out. And now you can see that our host should be able to ping. And we'll take a look at that. And you can see now the host can ping, right? Can communicate across, but of course these hosts probably still can't. Nope. See that? Destination host unreachable.